everyone. In this video, we will learn how to calculate concentration of ions and mass of precipitates in solution. We will solve problems regarding these concepts. Number 1, find the molarity of all ions in a solution that contains 0.165 moles of aluminium chloride in 820 milli solution. Let us start by writing the given. So we have given number of mole for aluminium chloride 0.165 moles, and the volume is 820 milliliter. Before finding the ions, let me find the concentration of the substance itself, and then we split into the corresponding ions. Concentration, it's the number of mole over volume, where definitely units here should be mole, and this should be liter, which is dm cube. Number of moles 0.165 over, here the volume given to us in milliliter, so simply we divide by 1000, so to be 0.820 liter. So it will be over, we will continue 0.820, and the answer up to 3 significant figures 0.201 molar. Now this substance is soluble in water, so it splits into its corresponding ions, Al3 plus, and as you see we have here 3 chloride ions, so plus 3 chloride ions. We will apply stoichiometry to find the concentration for each aluminium ion and chloride ion. If this is 0.201 and the ratio here is 1 to 1, so this will be also 0.201, plus here we have to multiply by 3 because the ratio is 1 to 3, so 3 into 0.201, which is 0.603 molar, into 3 significant figures. So eventually the concentration of aluminium we found is 0.201 molar, and the concentration of chloride corresponds to 0.603 molar. Now let us move to the second question. Find the molarity of each ion present after mixing. Here we have mixing HNO3 that has 27 milli and concentration 0.25, and calcium nitrate that has 36 milli and 0.42 molar. When we mix two substances, it's very important for us to know if there will be a reaction or no. Here no reaction occurs. I will prove it for you. Calcium nitrate, it's aqueous, and nitric acid in a solution, it's aqueous, which means it splits into its corresponding ions. Upon double replacement reaction, this will be calcium nitrate again, and HNO3. So as you see, no reaction. All of these, they are in the aqueous form, and they are the same substances, same ions that will give, so no reaction. So just this is mixing with no reaction. I will start by listing the given. I have nitric acid with volume 27 milli and concentration 0.25 molar, mixed with calcium nitrate, as we proved no reaction, calcium nitrate with volume 36 milliliter and concentration 0.42 molar. Upon mixing these two, volume will be increasing. It will be increased. So this is a dilution problem. So we have to find the concentration for each substance, nitric acid and calcium nitrate, after mixing, and then we go to look for the concentrations for each ions. So the first step, find concentrations after mixing. I will find the concentration first of all for nitric acid after mixing. Since it's dilution, so CbVb equals CaVa. B definitely corresponds to before mixing, and A corresponds after mixing. Okay, what's the concentration of nitric acid before mixing? 0.25. So 0.25. The volume before mixing is 27. Concentration after mixing is the variable that I need to find, and the volume, I will assume them additive. So volume total, it's 27 plus 36, which is 63 milliliters. So times 63. Upon doing simple calculation, the concentration up to 3 significant figures will be 0.107 molar. Nitric acid, it's aqueous, so it splits into its own ions. So we have H plus and NO3 minus. So if the concentration of nitric acid 0.107 molar, and all the ratios 1 to 1, so the corresponding will be 0.107 molar and 0.107 molar for nitrate ion, and H plus coming from nitric acid. Similarly, I will find the concentration after mixing for calcium nitrate. So I need to find the concentration after mixing for calcium nitrate. Again, it's a dilution problem because we are mixing, the volume increased, hence the concentration decreases. So dilution, CbVb equals CaVa. The concentration of calcium nitrate before mixing 0.24, so 0.24, volume before 0.24 or 42, 0.42. So 0.42, volume before mixing is 36. Concentration after mixing, it's the variable that I need to calculate, and the volume after mixing, we assume it additive, 63. So upon simple calculation, concentration after mixing for calcium nitrate will be 0.24 molar. Again, calcium nitrate is aqueous, which means it splits into its corresponding ions. So it will give us calcium ion Ca2 plus and 2 nitrate ions, so 2 NO3 minus. Again, stoichiometry is applicable. This is ratio 1 to 1, which means the concentration 0.24. This we have to multiply by 2 since the ratio is 1 to 2, which give us 0.48 molar. And these are the ions coming from calcium nitrate. Now let us write the final answer for the final concentrations. H plus, only one source of H plus, so I write it as it is, as we found it. H plus equals 0.107 molar. Concentration of Ca2 plus, only from one source it's coming, which is 0.24 molar. Nitrate ion comes from two sources, from calcium nitrate as you see, and also from nitric acid. So we have just to add the values. So 0.107 plus 0.48, which is equal 0.587 molar. And like this we found the concentrations after mixing. Number 3, calculate the concentration of each ion and the mass of any precipitate when 0.3 mole of aluminium hydroxide added to 50 milli of 2.5 molar nitric acid. So I will start by writing the given. So we have given number of mole for aluminium hydroxide is 0.3, up to 3 significant figures here. And for nitric acid given to us the volume, which is 50 milliliter, and the concentration, which is 2.5 molar. First of all, let me write the equation to see what products will be produced. So the aluminium hydroxide is insoluble or has very low solubility in water, so solid. Nitric acid, strong acid, and is soluble in water. Because it's a strong, drive the equation towards completion, Dow replacement reaction. So aluminium nitrate, this is aqueous, soluble in water, plus water, which is liquid. Definitely it needs balancing, so we balanced it like this. For every reactant here, there is a given, as you can see. So we have to check excess from limiting. Several ways, like 3 to 4 ways we use to check excess from limiting. The easiest way, that the one that I like and the students they like usually, is to find the number of moles for each one, and then to find the ratio of moles. The ratio of mole which is smaller will be the limiting, so the other will be excess. Aluminium hydroxide already given to me number of mole. Let me calculate the number of mole for nitric acid. So the number of mole for nitric acid is C times V. Definitely here should be divided by 1,000 to change into liter. So 2.5 times 50 times 10 negative 3. So the number of mole will be 0.125 mole. Now let me write in the equation the moles and find their ratios as a second step. The first line always according to Stoich, which is the ratio of the equation, and the second is the given, the one he gave it to me. According to Stoich, we have the ratio 1 mole of aluminium hydroxide corresponds to 3 mole of nitric acid. The given here we have 0.3 moles of aluminium hydroxide, and here 0.25 mole. Let me find the ratio for each substance. So the ratio of aluminium hydroxide, always it's the given over Stoich, which is 0.3 over 1, which is 0.3. Similarly, I will find the ratio for nitric acid of moles, which is also the given over Stoich, which is 0.125 over 3, that corresponds to 0.0417. Now we compare the ratios. The one with smaller ratio is limiting, so it makes, this is smaller ratios, it makes nitric acid is the limiting reagent, while aluminium hydroxide is in excess. What does this mean? Is in excess. What does this mean? It means at the end of the reaction, because aluminium hydroxide in excess, still we will have amount of aluminium hydroxide. This one will be totally reacted, so no nitric acid, and the products will be produced, which is aluminium nitrate. Okay, aluminium hydroxide, it doesn't produce iron, just I will calculate its mass, because he said find the mass. So the only source of ions will come from aluminium nitrate. Why? Because liquid, it's not a source of ion. Water, it's very weak electrolyte, produces very small amounts of ions. So the only source of ion is aluminium nitrate. First of all, let me find the mass of the precipitate by using definitely the limiting reagent, which is HNO3. So let me find the mass of the precipitate using the limiting reagent. I will take from the equation aluminium hydroxide and 3HNO3. The one that I will find is the mass of aluminium hydroxide reacted. I will use the limiting to find the one that the mass of aluminium hydroxide reacted. The first line according to Stoich, and the second given, and the required. This is why it was very important to check which excess, which limiting. Very important to know what reagents remained, and we, as we know, always only the limiting reagent is the one we use in calculation. Because I want to find the mass of aluminium hydroxide, so I will use the stoichiometry of aluminium hydroxide in grams. Here it doesn't matter, I can use moles. Okay, from the periodic table, atomic mass of aluminium 27, oxygen 16, hydrogen 1. So the molar mass of aluminium hydroxide 78 multiplied by 1, which is 78 grams. This corresponds to 3 moles of nitric acid. So the one we calculated, every one 0.124, 5 moles, should correspond to what mass of aluminium hydroxide? After doing cross multiplication, the mass of aluminium hydroxide reacted definitely. So from this calculation, I'm finding the reacted is 3.25 grams. So how can I find the mass left? Simply the mass the mass of aluminium hydroxide that is remained or left equal mass original of aluminium hydroxide minus the mass reacted. What is the mass original? Let us see. We have the number of mole of aluminium hydroxide. We can find its mass. How? Number of mole equal the mass over the molar mass, which means that the mass is the number of mole times molar mass, which is 0.3 times the molar mass of aluminium hydroxide 78, which is 23.4 grams. So this is the original mass of aluminium hydroxide that I will use, which is 23.4. The mass reacted, already we found it, 3.25. And the final answer is 20.15 grams. So this is the mass of the aluminium hydroxide precipitate that is remained. So the answer for what he wants, the mass of any precipitate, this is the mass of the precipitate aluminium hydroxide, which is 20. So remained, which is 20.15 grams. Now I want to proceed in my calculations and find the other part of the question, the concentration of each ion. As we said in this equation, this is precipitate, so no ions it will be given, or it gives very low amount of ion that I will neglect. The only source of ion is aluminium nitrate, so I'm gonna use the limiting reagent to find the concentration of aluminium nitrate. So I will say this is the ratio from the equation between nitric acid and aluminium nitrate. Again, stoic and given and required. The first line according to stoic, and then the given and the required. Speaking about concentrations, I will use moles. So every 3 mole from the stoic corresponds to 1 mole. Every 0.125 mole should correspond to how many moles of aluminium hydroxide? Upon crisscross, it will give me number of moles 0.0417 moles. Like this, I will be able to find the concentration, which is the number of mole over volume, 0.0417. The volume 50, definitely I have to change it to liter by multiplying 10⁻3, so 0.834. Now I will split the aluminium nitrate into ions because he's asking about the ions. Since it's aqueous, it splits its corresponding ions. So Al3 plus 3 NO3 minus. Ratio, stoichiometric ratio always applicable here, ratio 1:1. So aluminium 0.834 molar. This will be 3 into 0.834 molar, that corresponds to 2.5 molar. So eventually the concentrations of ions he's asking about, aluminium 0.834 molar, and that for the nitrate is 2.5 molar. Now the last problem that we will solve together we have 28 milliliter of 0.670 molar potassium carbonate solution is mixed with 15 milli of 0.94 molar solution of cobalt chloride, and now we want to find first of all we have to write the balanced equation. Okay, we have potassium carbonate and we have cobalt 3 chloride. So let me write the equation. Potassium carbonate, it's aqueous, plus cobalt chloride, COCl3, because as it's written, the cobalt is 3, Roman number 3, so it has charge 3 plus, also it's aqueous. Double replacement, so it will be CO2 into CO3, this is solid precipitate, plus KCl, and definitely it needs balancing, so I put 6 here, 2 here, and 3 there. Now write the total ionic equation and net ionic equation. Okay, so first of all, let me write complete or total ionic equation. Complete or total ionic equation, which is CIE. In the equation, only aqueous split into ions. Solid, I keep it as it is. So here we have, as you see, 4K, so I write 4K plus aqueous plus 3 CO3 2 minus aqueous. Also cobalt chloride, it's aqueous, so I split into ions. So 2 cobalt, 2 CO3 plus aqueous, and 6 chloride, 2 times 3, 6 Cl minus. Cobalt chloride carbonate, on the other hand, is solid. I do not split it into ions. I keep it as it is. But KCl aqueous, so I split into 6K plus aqueous and 6Cl minus. Now I subtract ions from both sides of the equation in order to write the net ionic equation. So net ionic equation, or NIE, I will subtract the common ions from the equation. Here we have 3 by 2, this is 6K plus, so we have to, okay. Now we have 6K plus and 6K plus, they are cancelled. And also common, we have 6Cl minus, cancel with 6Cl minus, and I'm left with these, so I will rewrite them in the net ionic equation. So the spectator ions are cancelled. So 3 CO3 2 minus aqueous plus 2 CO, definitely O here, it's small letter, CO3 plus aqueous to produce CO2, CO3, 3 solid. So this is the net ionic equation after I cancel the spectator ions K plus and K. After I cancelled K plus and Cl minus, they are the spectator ions. Now part C, give the name and mass of any precipitate that may have formed. The precipitate that has formed is cobalt chloride. Okay, so name of precipitate, name of the precipitate formed is cobalt 3 carbonate. Okay, now let me find its mass. I will use calculations definitely to calculate the mass. But as you see here again, for every reactant he gave me a given. For potassium carbonate, he gave me volume and concentration, and for cobalt chloride, volume and concentration. So I have first of all to check the excess from the limiting. Okay, so for potassium carbonate, I will find the number of moles. This is the way that we are using to check excess from limiting by changing first of all given into number of moles. So for potassium carbonate, I calculate the volume is 28 milli and the concentration 0.670. Definitely number of moles 6 is C equal N over V, which means N equals C by V. Definitely this should be divided by 1,000 to change it into liter. So 0.670 times 28 times 10 negative 3. And the number of mole of potassium carbonate I find is equal to 0.0188 moles. Okay, so we found it. Similarly, I will find for cobalt chloride. Again, N equals C times V, which is equal 0.940 times 15 times 10 negative 3, which is 0.0141 moles. So the number of mole of cobalt chloride 0.0141 moles. Now let me find the ratio to make up my mind which one is limiting, which one in excess. So I will take from the equation the reactants, potassium carbonate and 2 cobalt chloride. The first line according to Stoich, and then the given to find the ratio. Stoich, the ratio is 3 mole and 2 moles. Given, okay, for potassium carbonate I found it's 0.0188 mole, and this we found it 0.0141 mole. Now let me find the ratio for both. Okay, here in this, just let me check, right balanced equation, we wrote it. Give the name and the mass of the precipitate. Okay, just here for part C, we are on the right track. So the ratio for potassium carbonate moles, it's the given over Stoich, which is 0.0188 over 3, which is 6.27 times 10 negative 3. Now, similarly, I find the ratio for cobalt chloride. Also, it is given over Stoich, which is 0.0141 divided by 2, which is 0.0705. This one is smaller, so it means potassium carbonate is the limiting reagent, which makes cobalt chloride in excess. And as we agreed, always we use limiting reagent in our calculation to find what we want to find. So I'm gonna use the limiting reagent, which is potassium carbonate. So I will take from the reaction, we have 3K2CO3 to produce cobalt carbonate solid. Okay, I need to find the mass. So this is Stoich, this is given and required. Okay, I need to find the mass of cobalt chloride. From the periodic table, the atomic mass of cobalt is 58.9, for carbon is 12, for oxygen 16. So the molar mass of cobalt chloride multiplied by 1, it's 297.80 gram. Here, no problem, I can use the mole ratio. Every 3 mole correspond to 297.8, so every 0.9, the one that we found already, every 0.0188 mole should correspond to what mass? Cross multiply, and the mass of the precipitate cobalt carbonate equals to 1.87 gram. Like this we found the mass of the precipitate. Now part D, calculate the molar concentration of each ion remaining in solution after the reaction is complete. Okay, let me just rewrite the equation. 3K2CO3 aqueous plus 2COCl3 to produce CO2 CO3 3 solid plus 6KCl. As you've seen, we found already that cobalt chloride in excess. It means this part of it will be remained. So this is a source of ions. This one limiting, all of it reacted. Cobalt chloride, it's not a source of ion, it's solid, but this KCl aqueous, it's a source of ions. So we have two sources of ions that we need to find from them the corresponding equations. Now, first of all, let me find the amount of cobalt chloride reacted, and then I subtracted from the original to find the number of moles remained, because the number of moles remained are the moles responsible for the concentration of ions left. So I'm gonna use a limiting to calculate. I'm gonna use the limiting to calculate the number of moles of cobalt chloride reacted. So plus 2 COCl3. The first line according to Stoic. The second is the given and the required. Okay, so every 3 moles should correspond as a stoichiometry to 2 moles of cobalt chloride. So every 0.0188 moles, this is the amount that we have, should correspond to how many moles? So the amount of moles here of cobalt chloride after crisscross, these are the reacted quantity that corresponds to 0.0125 moles after calculation. Now let me find the number of moles of cobalt chloride remained. This is the one of my interest, which is the number of mole of cobalt chloride original minus the number of mole of cobalt chloride reacted. Okay, the original, we found it already at the beginning, 0.0141. The reacted, now we found it, 0.0125 moles. So the answer after this, it will be 1.6 times 10 negative 3. I found the number of moles, so let me find the concentration, because he's asking about the concentration of ions, which is N over V, 1.6 times 10 negative 3 over the total volume multiplied by 10 negative 3 in order to change into liter, and it's 0.0372 molar. Since cobalt chloride is aqueous, so it splits into ions, which is cobalt 3 plus and 3 Cl minus. Okay, if here 0.0372 and Stoic is applicable ratio 1 to 1, so it is 0.0372 molar. This will be 3 into 0.0372 molar, which is equal to 0, this one, 0.112 molar. Okay, so this is a source of ions that they are left. I will circle them. The other source of ion, as we said, is the KCl. So let me calculate. Always I use the limiting to find what I want to find. So 3K2CO3, which is the limiting, corresponds to 6KCl aqueous. As usual, the first line according to Stoic, and the second line is given and required. Every 3 moles from the ratio correspond to 6 moles, which is stoichiometry. So every 0.0188 moles should correspond to how many moles of KCl? Upon cross multiplying, I will find that the number of mole of KCl corresponds to 0.0376 moles. Now let me find the concentration of KCl, which is 0.0376 divided by the volume and times 10 negative 3 to change into liter, which is 0.874 molar. Again, KCl is a source of ion, as we said. It's aqueous, corresponds, it splits into K plus and Cl minus, and Stoic is applicable. So if this is 0.874 molar and the ratio all 1 to 1, 0.87 molar and 0.87 molar. So these are also source of ions. Now let me gather what are the sources of ions. Cobalt, okay, no other source of ions, so I will write we found the cobalt to be 0.0372 molar. Cl minus, we have two sources, the one coming from cobalt chloride and the one coming from Cl minus, so simply I add them. So 0.112 plus 0.874 sum up to 0.986 molar. And the only source for K plus is this one, which is 0.874.